Today's session is focused on GitHub and Jira, and we will learn how they act as an essential foundation for modern software development and how they connect with Jira to enable powerful team collaboration. Let's take a quick look at what we will cover today. We will begin by understanding what a version control system is and why it is so important. Then we will dive into Git, its core concepts and how it works internally. After that, we will explore GitHub and how it enhances collaboration. We will go through key concepts like repositories, branching, merging, cloning, issues and other operations. Then comes the practical part where we will walk through some common Git commands step by step just to give a demo. And finally, we will connect everything with Jira and understand how teams manage real projects by linking tasks with code. Let's start with a simple situation. Imagine you are working on a project and saving files like project final v1, project final v2, maybe project final latest. So very quickly things become confusing. You don't know which version is correct, and if something breaks, you cannot easily go back. Now imagine doing this with a team, multiple people's editing the same file, overwriting each other's work, losing important changes, so this is a complete chaos. Version control system solves this problem. It keeps track of complete history of changes. It records who made what changes and when. It allows you to go back to any previous version at any time, and most importantly, it allows multiple people to work on the same project without interfering with each other. So this is not just convenience, it is critical for collaboration and reliability and scalability. Git is a distributed version control system. What makes Git powerful is that every developer has a full copy of the repository, including its entire history. This means you can work offline and experiment freely and still have complete control. Git doesn't just track files, it tracks the snapshots of your entire project. Every time you commit, Git stores a snapshot of the current state. This makes it incredibly efficient and safe. Now let's see the conceptual difference between Git and GitHub. Now many people confuses Git and GitHub. So remember that Git is a tool, that is, you can say, an engine that tracks changes. GitHub is a cloud platform built on the top of Git. It stores your repositories online and provides collaboration features like code reviews, the pull request and issue tracking. So you can say Git works locally while GitHub connects the team globally. A repository is the heart of Git. Think of it as your project folder, but much more powerful. It contains your code, your files, and complete history of every change you made. There are two types of repositories: the local repository existing on your system or machine. Remote repository exists on platforms like GitHub. When you work, you make changes locally and then push them to remote repository so others can also access them. Now comes one of the most important concepts in Git, that is branching. In simple terms, branch is a separate line of development. Imagine your main project is stable. Now you want to add a feature. Instead of changing the main code directly, you create a branch. This allows you to experiment safely without breaking the main project. For example, consider that you are developing a project with the team and you finish a feature. You contact the client and request them to see the feature, but they are too busy, so you send them the link to have a look for the project later. So the project development, assume that it goes through the linear development. So you have been working on a project with a client happy until this point. So master basically indicates the last snapshot or the reference to the last commit object of the branch. Now you decide to develop a feature and start working it on the same code, that is denoted by the black commits. You show this to your client, and in the meantime you decide to develop another feature, let's say XYZ, and wait for the client's approval. So let's assume the client disapproves the feature, that are your black commits, and request you to delete it. Now since you are following the linear development, you need to delete the complete code and go through the hectic process of the adjustments and removing the glitches repeatedly to achieve the picture that is shown on the screen. So let's see how branching helps us. So let's assume the same scenario. So you have been working on the project with the client being happy, so until this point, and after that you decide to develop a feature and create a branch called feature for the same purpose and start working on it. You show this to your client. In the meantime, again you decide to develop another feature and wait for client's approval. So client disapproves the feature, for example, and requests you to delete it as done previously. So now, since you are following the branch strategy, you need to remove this branch shown as highlighted. So all the remaining code remains as it is. The new feature can be later added to the master branch, so it gives you a freedom to independently work on different modules and merge the modules when you finish to develop them. Multiple developers can create multiple branches and work in parallel, so this is why modern development is scalable. Once the feature is complete, the branch is merged back to the main branch. Without branching, as we have seen, the development would be linear and extremely risky. And with branching, it becomes parallel, safe and organized. When branches are merged, Git combines the changes. Sometimes two people may edit the same part of the file, so this creates a conflict. So Git doesn't guess, it asks you to resolve the conflict manually, and this ensures the accuracy and control. In GitHub, the issues and branches serve different purposes. Issues are used to track the bugs, the task and feature request. So they answer the question like what needs to be done. Branches represent the actual work being done in code. They answer the question like how it is being done. Together they create a complete workflow that is planning and execution. In Git, every file in project can exist in one of the three main states: modified, staged and committed. And understanding the transition between these states is crucial for managing the changes effectively. When you make any change in a file in your working directory, Git recognizes that the content has been altered compared to the last saved snapshot. This is called the modified state. At this point, the changes exist only locally. They are not yet part of the project's recorded history. Git tracks that something has changed, but it doesn't automatically include those changes in the next version. Once you have reviewed your changes and decided which ones you want to include in the next snapshot, you stage them. Staging is an intermediate step where you can explicitly tell Git which modifications should be part of the next commit. Staging doesn't alter the working directory, it simply prepares a clear and you can say controlled set of changes to be saved. You can stage all changes or selectively stage certain files or even specific lines within a file. This flexibility allows you to organize the commits logically, grouping related changes together. After staging, the final step is to commit the changes. Committing takes the stage snapshot and records it permanently in the repository's history. Each commit acts as a checkpoint that can be referenced later, allowing you to review, revert or branch from it. Once a commit is made, the staged changes becomes part of the project's official history and Git considers them saved. From there, any new edits to the file will again move them to the modified state, restarting the cycle. In summary, the workflow flows naturally. You modify files to make changes, then you stage the changes you want to save, and you commit them to record them in the repository. So this separation ensures that you have complete control of what gets saved and keeps your project history clean and organized. Let's begin by installing Git on your system. So first open the browser and search for Git download. You will find the official website at git-scm.com. You download the version suitable for your operating system, so whether it is Windows or Linux. So in my case it is Windows. In Windows you run the installer and keep the default settings. These defaults are optimized for most users, so you do not need to change anything. Once the installation is complete, you need to verify it. If you are on Windows, open the command prompt, type the command like git -- and version. So this commands check if the Git is installed correctly. If it is installed correctly, you will see the version number displayed that confirms everything is working. Now let's create a real project to understand everything step by step. Imagine you are building a simple website, for example this basic HTML page for company landing page, for example. First create a folder on your system. You can do this manually or through the terminal. Let's say we create a folder called my website. Now open this folder in your terminal and navigate using the cd command, like cd my website. This is where all your work will happen. Now let's create a simple HTML file. Inside this folder, create a file named index.html. Open it in any editor like VS Code, or write a simple structure like shown here. So save the file. Now we have a basic project ready. Next step is to initialize Git repository. Now we bring Git into the picture. Inside the same folder in your terminal, type git init. This command initializes a Git repository. What it does is create a hidden folder named .git, which will track all the changes in the project. At this moment, the Git starts watching your project. Now let's see what Git detects. Type git status. You will see the index.html is an untracked file. To tell Git to track it, we use git add index.html. So now the file is staged. Next we commit it. So now that we have staged our file, let's try to commit it by typing the command as shown there, git commit -m and then a message. In this case it is initial commit with index file. Now in many cases, especially if it is your first time using Git, you might see an error instead of successful commit. So the message usually says something like author identity unknown and asks you to configure your name and email. This happens because Git needs to know who is making the changes. Every commit is recorded with the author name or email. So without this information, Git cannot proceed. So to fix this, we need to configure Git with our identity. In the terminal, type the command as shown on the screen to set your email. Git config, then global, user.email, and then your email. In my case, it is natalia.chaudhary@pucit.edu.pk. So these details will be attached to every commit you make. The --global flag means this configuration applies to all your projects on this system. Now that Git knows who you are, let's try to commit again. So come again with the same command, but this time the commit should succeed. And just like that, you have created your first snapshot in Git. Now imagine you want to add a feature, maybe a contact section. Instead of modifying the main code directly, we create a branch with the command like git checkout -b and feature contact. Now you're working in a separate branch. Edit the HTML file index.html and add this content. Then type the command git add, then commit -m and with the relevant message. So git add dot is used to stage the changes, but the dot has a very specific meaning. The dot represents the current directory and everything inside it recursively. Essentially, the dot is a shortcut for saying that everything here and below. Without the dot, Git doesn't know which files you want to stage. You could stage the files individually with git add and then file name, or by this method, that dot sign. So this change is now isolated in your feature branch. Once the feature is complete, we need to merge it back. We write git checkout master git merge feature contact command. Now the main branch includes your new feature. If everything looks good, you can delete the branch git branch, then D, and then feature contact, the branch name. Now let's bring GitHub into the workflow. Go to GitHub and create a new repository. Copy the repository URL. Now link your local project to GitHub with the command like git remote at origin and then repository URL. Push your code with the command git push and origin master. Now your project is live on GitHub. By the way, at any step, if you want to stop the execution, so on Windows you can press Ctrl+C to stop the current Git process. So if another developer makes changes, you can fetch the updates using git pull, and whenever you make changes, you upload them using git push command. Now let's extend this to a real-time workflow using Jira. Imagine a task is created in Jira with the name as user can log in securely. Now instead of naming your branch randomly, you create one like git checkout and DDA7 login. When you commit, you include the Jira ID. So you write the command as git commit with -m, and then in the command you can mention the Jira ID like DDA7 and message like login functionality completed. So this connects your code to Jira task. For complete exploration of Jira, you can refer to the playlist with the sessions on Jira. That gives you a complete walkthrough of Jira and all the relevant concepts and hands-on related material there. A task is created in Jira. You create a branch in Git using the task ID. So you write code and commit changes. You push the branch to GitHub and you create a pull request. Your team reviews and merges it. Jira automatically updates the task as completed. So this creates a seamless flow from planning to execution, and that's how modern development works. You start from installing Git, created a project, tracking changes, use the branches, collaborated with the help of GitHub, and connect everything to Jira. So this is not just theory, this is how real software teams work every day.
Before we jump into creating branches and working on GitHub, let's first understand an important concept, that is cloning a repository. Cloning means create a local copy of your remote repository on your machine. So this allows you to work on the project files locally, make the changes, and later sync them back to the remote repository. To clone a repository, we use the command git clone and then the repository URL. In this case, the demo git repository. Once you run this command, Git will download the entire repository, including all the files, the history and the branches onto your system. After cloning, the next step is to navigate into the project directory using the cd command. Now before we start making any changes, it is a good practice to switch to a specific branch or create a new branch for your work. To switch to an existing branch, we use git checkout command. And if the branch doesn't exist, we can create and switch to a new branch using git checkout and then -b and the new branch name. So this helps us in keeping your work organized and avoids directly modifying the main branch.
Now let's add a new feature to our website. Instead of modifying the main branch directly, we will create a branch called feature about. Now you are working in a feature about branch. Any changes you make will only affect this branch. Modify the HTML file index.html. Let's add a new section about the company. So open the editor and add this section and save the file. After editing, Git needs to track these changes. First we stage them again using the add command, git add and then name of the file. Then commit with a meaningful message like git commit m and then the meaningful message like added about us section in the HTML file. This snapshot is now saved in the feature about branch. Once the feature is complete and tested, we merged it back to the main branch. First switch back to master with git checkout master command, then merge the feature branch with git merge command. If there are no conflicts, Git will integrate the changes and the about section is now part of the main branch or master branch. To share your updated master branch with the team, push the changes to GitHub. So with the command like git push origin master, now everyone can see the about section on the remote repository. After merging, you can safely delete the feature branch locally with the command like shown there. Everything I just described can be done entirely on GitHub through its web interface without touching the terminal. So the workflow is slightly different but very intuitive. Let's see how it works. So to create a branch, you go to repository on GitHub. You will see a drop down near the top left label master of your default branch. Click it, type a new branch name like feature about and press enter. GitHub will create a branch for you directly on the server and you are now on this new branch in the web interface. Next, edit the files directly on GitHub. So you navigate to index.html in your repository, click the pencil icon, edit this file, add your about section, scroll down to the commit changes section, enter a commit message like added about the section in the index.html. Make sure that this thing is selected as commit directly to feature about branch. Click commit changes. This saves your changes directly in the branch you created. Now let's see how to create a pull request to merge. Navigate to the pull request tab on GitHub. Click new pull request. Select master or main as a compare branch. First update a line in index.html for example, and then delete index.html file from the feature about branch. So you will notice that GitHub will show the changes. You review them, and you can review them and then click create pull request. Enter a title and description of the pull request and create pull request. So this is equivalent to merging locally with the git merge feature about. After reviewing, click merge pull request, confirm the merge. Now the changes made are reflected in both the branches. Finally, GitHub will show a delete branch button to delete a branch. So you do not need git add or git commit on the terminal. GitHub handles all the staging and committing in the web editor. Branching, merging and deleting all can be done in browser. So this is perfect for small changes, demos, or for beginners who haven't set up Git locally yet. So for larger projects or multiple teams, using the local Git workflow is still preferred. So to summarize, Git provides version control and GitHub enables the collaboration, and Jira manages the tasks. Together they form the complete workflow system for modern software development. So understanding these tools is not an option, it is essential for working in a professional development environment.